started. There we go. Sorry. That's my third one today. It's going to mess up on me. Okay. This one's going to be short and sweet. We'll talk about how you can form a concentrated or dilute urine. And you guys already know that you do this. You've never even taken this class before, and you know this happens. You've been out on a hot day. You haven't had enough water. You didn't drink enough. You sweated. You've gone to the bathroom. You look at your urine, and it's a really dark orange color. You're like, oh, my gosh, I must be dehydrated. And so what your body has done is trying to conserve as much water as it can, so it has concentrated your urine. It's getting rid of all those toxins. You're still filtering. You're still making filtrate. Reabsorption and secretion are still going on, but you're trying to hold as much water as you can to keep your blood pressure up, okay? Keep yourself hydrated. If you have maybe gotten up maybe drank a big old Coke, or a big old glass of water at lunch, maybe a big old thing of tea at a Mexican restaurant, they're about that big. Maybe an hour later, you really got to go to the bathroom. You go to the bathroom and it's clear. So you've got to really dilute urine. You're still getting rid of all that waste products, but you're getting rid of that extra water too. So you're basically either making more concentrated or more dilute urine. We're going to talk about a little bit about how that process occurs. It's really a complicated process. I don't want you to get too bogged down in it, just kind of a brief overview of what's going on there. Because you know your body does it. We've already realized that. One thing you may not know if you're trying to figure out, especially if you're trying to travel and trying to figure out, how fast your kidneys work, they're actually pretty efficient. It takes about 90 minutes for what you drink to then be excreted out as urine. Okay, so if you're about to get on a plane, don't drink a big old, in 90 minutes, don't drink a big old glass of water right before you get on the plane if there's no bathroom. So just kind of heads up on that one. Takes about 90 minutes. And you've probably noticed that. You're smart. You've kind of figured out what your body's doing over time. So how do we make this this urine that's concentrated or dilute? The mechanism's called the countercurrent mechanism. And it's basically when you have a fluid flow in opposite directions. And it takes place between the loop of Henle and the vasa recta. So let's go ahead and flip over to the next slide. Here's your nephron. You have your loop of Henle and your vasa recta. Okay? These are the three players. Also the collecting duct. So your nephron loops, your vasa recta, and your collecting ducts. These all work in varying the concentration of urine, making it more concentrated, dark in color, or more dilute. What we're looking at is basically a gradient, an osmolality gradient. So what your body does, what your kidneys do, is they establish a gradient inside the medulla of osmolality. If you want to substitute the word saltiness, that's okay. You'll kind of maybe understand what I'm talking about. It's more salty as you go deeper into the medulla than it is near the cortex. And this gradient allows for us to concentrate our urine. Okay, how does that work? It has to do with the selective permeability of the different parts of the nephron. And specifically, the descending limb is permeable to water. Okay, so water can readily leave the nephron and go into the interstitial fluid. Just goes right on out. When it does that, it leaves the salts behind. Now, in the ascending limb, it's impermeable to water, but it is permeable to sodium and chloride. Okay, so let's go ahead and flip on to this next slide. So you see that in the descending limb, permeable to water. So all the water, not all the water, but a lot of the water, at 95%, is going to be reabsorbed out of the descending limb. If the sodium is still in there, it's not leaving, right? It's becoming more concentrated, more salty. So as you go down, the concentration goes up until it reaches about 1,200 milliosmoles. Don't worry about the numbers. As you turn the corner, turn the loop, go back up, the water no longer can leave. It's impermeable to water, but it's permeable to sodium chloride. So the same amount of water, the water's traveling through, okay, but the sodium chloride is leaving. So the salt is leaving. So now your water's becoming more dilute. The osmolality is going down. Okay? So that's how you concentrate the urine. You suck out all the water, okay, but you don't want to get rid of all your sodium chloride. You need to retain some of your sodium and chloride. You're not trying to get rid of that. You want to hold on to it. You don't want to just pass that out and urinate a little salt block. You want to hold on to your sodium chloride. So now you've gotten rid of you've held on to your water, and now you're going to hold on to your sodium chloride. And the way it does that allows you to concentrate the urine. Now all that's going out into the water and the sodium chloride are going out into the interstitial fluid. Then you have the vasa recta, which is basically permeable to both sodium and water. And so as the sodium and water leave the nephron and go out into the interstitial fluid, it's then reabsorbed or goes back into the blood. Now, the way that vasa recta surrounds that nephron allows you to preserve that gradient. It keeps that gradient intact, all right, so that you can then concentrate the urine. Now, to fine-tune the final concentration of the urine, you need to use the collecting duct. That's kind of the fine-tuning of urine concentration occurs. So in the collecting duct, it's under the control of antidiuretic hormone. Okay, so the amount of antidiuretic hormone will determine the final concentration of the urine. All right, because to diurese means to put out urine, so antidiurese would mean to hold back urine. So based on how much antidiuretic hormone you're releasing depends on how much water you're reabsorbing, or how much water is going to go straight out into the urine. So to form a dilute urine, okay, you have your filtrate, you have your reabsorption going on in the proximal convoluted tubule, and now you've concentrated it through the loop of Henle. Okay? In the absence of antidiuretic hormone, okay, you are going to make a dilute urine, all right, because you're not going to want to hold back any water. You're in the absence of antidiuretic, you're going to make a dilute urine. You may also remove some more sodium and other ions in that distal convoluted tubule and the collecting duct. You can dilute the urine to really, really low, about 50 milliosmoles, which is very low. When you consider blood is 300, you can have very, very watery dilute urine if you're trying to get rid of a lot of water. Now, what if you need to hold on to water? It's a hot, sweaty day. You need to conserve as much as you can. You got to have that osmotic gradient intact, and that's one thing that if you drink too much water, you actually, and if you have some kind of maybe a renal problem, if something's going on in your kidney, maybe they're not quite functioning right, that gradient can kind of get messed up. It can happen, and when that occurs, you can't make a concentrated urine. But depending on this osmotic gradient and your levels of ADH, you'll form a concentrated urine. Because remember, ADH triggers the reabsorption of water in the collecting ducts, okay? And so in the presence of ADH, 99% of your water is reabsorbed. So all that water is coming back, very concentrated urine. So another thing that you've heard about maybe is a diuretic, okay? And this is something that will enhance or increase urinary output. A lot of girls or people will take this to try to lose weight, lose water weight. Basically, you're just getting rid of excess fluid. And there's several different types of diuretics that will cause you to have increased urinary output. There's osmotic diuretics, and basically that's something that's not reabsorbed. So think about a big thing, such as a big chemical or a big compound, such as glucose, that's not reabsorbed. So it's going to, remember that osmotic pressure, that sucking pressure? It's basically going to hold on to the water and cause more water to flow out. That's what happens in diabetes. Okay, and so when somebody's diabetic, especially like diabetes mellitus, where they've got high blood sugar, there's too much sugar going into the filtrate. The kidney can't reabsorb it all. There's too much sugar in the blood, so therefore more sugar in the filtrate than the kidney can reabsorb. That sugar holds on to the water and causes you to have a more dilute urine, so you urinate. A lot of times that's one of the first signs of someone being diabetic, is that they are urinating a lot. Alcohol inhibits antidiuretic hormone, so it acts as a diuretic. And then some things that will inhibit sodium reabsorption. If you inhibit sodium reabsorption, then sodium's going to go out. Water follows sodium always. So if you're not inhibiting, if you're not reabsorbing sodium, you're not reabsorbing water. And caffeine is one of the things that does that. So you drink a cup of coffee and you have to pee a lot. It's because you're not reabsorbing sodium, and so therefore you're getting rid of a lot of water. Okay, that was short and sweet. So I got one more to do, and I will get that done, and we are almost done. So hang in there. Again, if you have any questions, come find me. I'm on campus, so just come ask, and I will try to straighten it out if you're confused about anything, or obviously you can talk to your instructor, and I'm sure they can explain it to you just as well, or maybe even better. All right, see ya.